Okay, good morning or good afternoon or good evening. This is my first video of this year, 2016-2017, lesson 2.1 from our textbook, rates of change and limits. Okay, my first clip, expect each clip that I upload to be about 5 to 10 minutes in between that long. So we'll start. Okay, average rate of change or the average speed is at the introductory section of the lesson 2.1. You're familiar with this idea because the average rate of change is another word for another term that we're familiar with, slope. The slope is defined to be the rate of the rise to run, delta y divided by delta x, which could be found by finding the difference between the y values over the difference in the x values, okay, between the 2 points, any 2 points of a graph. In this case, it's 2 points of a curve. Okay, so again, f of x sub 2, that's just your y2, f of x sub 1, y1 over x2 minus x1. You could write this in this notation, f of x plus h minus f of x all over h. Some people call this the difference quotient formula. It's basically your slope formula written in a different form, different notation. We know that, okay, if you have 2 points, okay, assume that you have these 2 points. The first point being x sub f of x, and your second point being, okay, second x value being h units away to the right of x. So x plus h will be the x coordinate value for your second point. And as a result, f of x plus h would be your corresponding y value, okay, for this point. Now, if I want to write a ratio, okay, to represent the slope or the rate of change, you simply use the concept of the slope. Rise over run, so y2 minus y1 over x2 minus x1. So let me use a different color for that. So you have y2 minus y1 over x2 minus x1. Okay, so this is your slope, or this is your rate of change between those 2 points. Okay, we also call that this is the slope of the secant line, the line that passes through the curve at 2 points. And when you simplify this simply becomes f of x plus h minus f of x all over h, because your x's will cancel out. Okay, you're left with h, and there we have it. Okay, so f of x plus h minus f of x all over h. Okay, so let's take this idea. Okay, you could use this formula, this new formula. Okay, or you could just use the old formula of the rate of change or the slope to answer question 1, example 1. You could also read this from page 59. For this problem, we're given the equation y is equal to 16t squared, where t represents the time after the rock was launched, or it was dropped in seconds, and y, I initially thought y was the height of the object, but it's the vertical distance covered by that drop. And the unit for this variable is in feet. So we got y is equal to 16t squared. This will be provided for you. And then we're trying to find the average rate of change, or the average speed during the initial 2 seconds, first 2 seconds of the fall. Okay, so one way to figure this out, okay, we know that the independent variable, or the x, or in this case t, starts with 0. Okay, the initial y value, okay, when the x value or the t value is 0, would be 0 squared times 16, which will be 0 as well. But then after 2 seconds, okay, let's substitute 2 in place of t. 2 squared is 4. 4 times 16 is 64. So 2 comma 64 would represent your second point of the graph. If you were to draw a graph for this, this means that after 2 seconds, your vertical distance that was covered was 64 feet. So to find the average speed, all you have to do is use the slope formula, which is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. which is the same thing as 64 minus 0 divided by 2 minus 0. And that gives you 32. And the unit for this one being feet per second. Okay, so that is your average speed. Okay, but you could have used this new formula as well to find to solve the same problem. You could have done so if you're looking at, so we're still in example 1, but if you're looking at this formula, okay, your x value would represent the initial x value, or the initial t value in this case, and the h value would represent the difference between the difference in the x value between the first point and the second points, or in this case, in our case, that will be 2 seconds, first 2 seconds, so your h value will be 2. Okay, so what you have is f of 0 plus 2 minus f of 0 divided by h, which is 2. And that comes out to be 64 minus 0 divided by 2 as well, which is 32 feet per second. Okay, so there's my example 1.